Once upon a time there was a little student. His name was Einstein. He dreamt of writing on a light ray. His result then became known as the special theory of relativity. At that time in Europe, where he lived, the first fully operational elevators, as we know them today, had launched their service. Einstein's interpretation is known as his general theory of relativity. Only he had had problems with mathematics, therefore he consulted a friend from university, Rossmann, introduced him into differential geometry. But alas, this led Einstein to absorb the classical continuum physics that tightly that it unilaterally blocked his further imagination until his death. Although Einstein correctly had recognized the photon a quantum object, his mathematical lack of awareness concerning the methods of group theory reduced his combinatorial strategy to purely symmetrical and anti-symmetrical representations. Bose-Einstein and Fermi-Dirac statistics, respectively, important notions like that of irreducibility and separability thus passed beyond him. His own idea of a background independence just as some poor version of it. During the 1920s, quantum mechanics had been founded on Planck's discrete quanta. Again, however, people just retranslated it into some continuous description. By functional analysis, Schrodinger's view, according to which quantization merely meant some curious cooking recipe nobody really took seriously. In spite of its use for calculation, physical argumentation still followed the old beaten track of classical physics, thus minimizing the chance of finding novel features. Planck's revolutionary ansatz of discrete quanta thus got lost again, both in Einstein's works and in those half-hearted formulations of quantum mechanics. That classical refusal of trying to understand the most primitive rules of combinatorial analysis on an atomistic level, as it is mediated by group theory, converted to an essential characteristic of an entire century. Corresponding mathematics young to blow had been well known, only people did not care about it because schools preferred to teach the infinitesimal methods of the 18th century, but no combinatoria analysis in Austria. Schrödinger and Pauli even came up with a critique stigmatizing this type of mathematics, which once should have a good chance of unifying Einstein's general relativity with quantum mechanics to a common quantum gravity as group pestilence. From the perspective of a particle theorist or of a theoretical cosmologist, hence the last 100 years will have to be ticked off as a lost century where the theory of fundamental physics just lived on its substance. In those times, theory did not really process the experimental findings. Their standard models just are busy with fitting, they do not explain anything. However, with general relativity as a one-man project on the one hand and with quantum mechanics including its other hand, a glorious epic of physics dried up, whose glamour shortly flared up just another time with gel. Man's quark model, in order to be destroyed at birth, again by the continuum theoreticians, the relativity of space and time, had shaken the fundaments of classical philosophy, and so did it even more abstractly. The concept of a world of quanta, Einstein's quasi-idealization, widely accepted still today, has its roots in the fact that he had proved to be one of the last advocates of a serious theory of fundamental physics, which, still based on cognition and not purely on administration,